Welcome to Brain Vision.
For this example, we're going to figure out how many homes we can power with the internal energy of a giant chamber of ideal diatomic gas that's kept underground. And this chamber has a volume of 5.6 times 10 to the 5th meters cubed, and it has a pressure of 7.7 times 10 to the 6 pascals. So much, much greater than atmospheric pressure. And we're assuming that the energy a single household will use in a day is 30 kilowatt hours. Now we're also told that for a diatomic gas, the internal energy is not 3/2 nRT, it is actually 5/2 nRT. All right, so to figure out how many homes we can power for a single day, we will want to take the total energy that we have stored here, and we will want to divide it by our energy that a home requires each day. So this should give us the number of homes that we can power for a single day. All right, so the total energy for us is just going to be U, our internal energy, and the energy per day is something we already know right up here. So all we have to do is calculate what our internal energy is, plug it into this equation, and we'll be good to go. So U is 5/2 nRT, where we actually don't know the number of moles we're dealing with. So we'll have to do something a little clever here. And we also don't know the temperature. But if you notice, this right here looks just like the right-hand side of the ideal gas law. Right? The ideal gas law says PV equals nRT. So we could just substitute out that nRT for P and V. And if we did that, we'd have 5/2 PV. And the reason we do this is because P and V are actually parameters that we have the values for. So now we can go ahead and calculate our internal energy. And if we do that, we're going to get a value of 1.078 times 10 to the 13th joules. So that's the total energy we have to spend. Now we know each day, each home is going to take up this much energy. So we really could call the units on this thing up here kilowatt hours per home, just so it's nice and clear. That when we do our final calculation, the units will just come out to be homes. All right, so the total number of homes we can power in one day is going to be our total energy, U over 30 kilowatt hours. And we'll want to convert that kilowatt hours real quick. So in 30 kilowatts, there are 30 times 10 to the 3rd watts. And then in 1 hour, we know there are 3,600 seconds, which is a very, very useful conversion to remember. 3,600 seconds. So that is going to be 1.08 times 10 to the 8th joules. So instead of 30 kilowatt hours here, we can write 1.08 times 10 to the 8th joules. Okay, so if we do that and we plug those numbers in, we'll get that the number of homes we can power is 99,818 about. Or if we respect our significant figures here, we'll just go to the second digit and we'll end up with 10,000 homes. So we could power 10,000 homes for an entire day just with this single storage of underground gas.